Physics Paper 1, Energy, Changes in Energy. For this question, it would be ideal to have a calculator handy. For energy changes, it will also be important to revise 3 key equations. Kinetic energy, EK equals half mv squared, where m is mass and v is velocity. Elastic potential energy, E equals half ke squared, where k is the spring constant and E is extension. And gravitational potential energy, where m is mass, g is gravitational field strength, and h is height. Remember, energy is measured in joules. Worked example, gravitational potential energy. So we've got a calculation question. So we enter our information into guess. So what are we given? We're given the energy. We're given mass. And we're also given gravitational field strength. The units look fine to me, so we can put a tick. The equation is, state the equation first. Let's substitute in now. We've got the energy. We've got mass. We've got gravitational field strength. However, we have not got the height. That's what we are looking for. We want to get h on its own, so therefore we are going to divide this side by 8,000 times 9.8. Type that into the calculator. And you'll get an answer of 0.25, and that will be in meters. So here's the GCSE mark scheme. As you can see, 1 mark for correct substitution. There'll be another mark given for rearranging to then go on and calculate the height, which was 0.25. How did you get on? Practice GPE. So here's one for you to have a look at. We've got a skier on a ski jump. Calculate their GPE at the top of the ramp, at the start of the ramp. It's a 2-mark question. Use the equation, use the guess method. Pause the video and have a go. Here's the GCSE mark scheme. As stated, only 2 marks on offer, 1 for correct substitution and then 1 for correct calculation and answer. How did you do? Worked example, kinetic energy. For a question involving a calculation, I would write, you guessed it, guess, down the side of my page first. Then, looking at the question, I would next annotate it. So I've got 81 kJ, 81 kilojoules. So E equals 81 kJ. And then I've got mass equals 8,000 kilograms. Now for units, I don't want energy in kilojoules, I want it in joules. To get joules into kilojoules, times by 1,000. So E equals 81,000 kilojoules. State the equation. Kinetic energy equals half times mass times velocity squared. And then substitute. We've got energy, 81,000, equals, instead of half, I'm going to use decimals. So half is 0.5 times 8,000. I'll put that in brackets. Times V squared, because that's our unknown. Okay, to get the V on its own, we need to get rid of the 0.5 times 8,000. And to do that, we divide it by 0.5 times 8,000. Let's use a different colour. Divide by 0.5 times 8,000. Whatever you do to one side of the equation, you must do to the other. So it's going to be that V squared is equal to 81,000 divided by bracket 0.5 times 8,000. This equals 20.25. But that is for V squared. To find V, we'll need to find the square root of this. So the square root of 20.25 in the calculator gives me 4.5 meters per second. Here's the GCSE mark scheme. 1 mark awarded for correct conversion of 81 kilojoules into joules. 1 for correct substitution and then subsequent rearrangement, and then the final mark given for the answer, 4.5 meters per second. How did you do? Practice kinetic energy. We have the skier on the ramp again, but this time the focus is on the kinetic energy of the skier at the end of the ramp. The skier has a mass of 80 kilograms and 36,000 joules of GPE at the start of the ramp. Calculate the speed of the skier when he leaves the end of the ramp. Assume there is no friction. 4 marks on offer. Pause the video and have a go. GCSE mark scheme. So how did you do? 1 mark was awarded for realising that the gravitational potential energy at the start of the ramp was going to be transferred into the kinetic energy at the end of the ramp. 1 mark given for EK equaling 36,000 joules. Then 1 mark for substitution into the equation. 1 mark then given for calculating V squared. And then finally, finding the square root of your answer for V squared to give you 30 meters per second. Worked example, elastic energy. This is a calculation question. So let's write guess. We're looking to find the spring constant. So we should be dealing with this equation. look at what we're given. We're given energy as being 770, but this is gravitational potential. But it does go on to say that 14% is transferred to elastic potential. So my EE will equal 770 times 0.14 to get that percentage. Looking at this paragraph now, it talks about extension. The extension is from 35 to 42. So 42 minus 35 gives me 7. So my extension equals 7 centimetres. We don't want centimetres, we want metres. So let's convert that first. Divide by 100. 100 centimetres in a metre. And we will get that E equals 0.07 metres. Might as well calculate this. Let's substitute into our equation now. So I've got my energy, 107.8 equals, instead of the half, let's put the decimal, 0.5 times the unknown K times 0.07 squared. We want to find K on its own. So we will need to divide 107.8 by 0.5 times 7. Careful. 0.07 squared. Type that into your calculator and you will have K. (107.8) divided by 0.5 times brackets 0.07 squared, close the brackets. I get an answer of 44,000 and the unit is newtons per metre. Check this against the GCSE mark scheme. Mark awarded for realising that you had to work out the percentage of energy that would be transferred. Mark given for converting the extension into metres. Mark given for substitution and then calculating. Practice elastic potential energy. So we've got a door lock and we've been provided with information. It's given us energy, it's given us the spring constant, it's asking us to find the extension. Please be very careful with this question, because the answer is being asked for in millimetres. Pause the video and have a go. Here's the GCSE mark scheme. Marks were given for correct substitution, rearranging, finding the value of E, and then making sure that the answer was given in millimetres. Remember, there are 1,000 millimetres in a metre.